The first step for Civil 3D bridge interoperability is to publish the bridge model from Infraworks that has been created using the enhanced bridge design workflow. Once the bridge model has been published, it is available for use in Civil 3D. Opening the published Infraworks bridge model links it to Civil 3D, where the bridge model can assist in a variety of tasks, including grading operations, as well as producing further views and documentation, such as developed long sections. When changes occur, those can also be easily accommodated by publishing an updated version of the bridge from Infraworks, together with notes identifying the changes made. We are then notified of changes in Civil 3D, and those changes can be adopted in the Civil 3D bridge model by refreshing the dataset.
Infraworks 2021 now utilizes the power and precision of Civil 3D for corridor models. Once the user has developed the geometric design details and created the corridor model, they can import their corridor directly into Infraworks. Options have been added to give the user greater control of how they import alignments with corridors from Civil 3D. This improvement allows users to import all the calculated design elements or just select elements. Users can define the mapping of materials to apply to the corridor shapes, and the fully designed roadway corridor is placed in its contextual environment. Downstream functions, such as bridge and tunnel design, can be carried out on the detailed design geometry. The corridor model in Infraworks is read-only, but is linked to Civil 3D in a connected workflow. When revisions are made to the corridor, either alignment, profile, or assembly-related modifications, users can simply rebuild the corridor, save the changes, and easily update the connected Infraworks model. Users can select the corridor under Data Sources and choose the Re-import option. The updated corridor will automatically load in the model. Users can view the geometry of the entire corridor, including profile and section views. This added capability gives users greater control and helps to enhance the workflow connection between Civil 3D and Infraworks.
For the AC Collection 2021, Autodesk has released an enhanced bridge design workflow for bridge professionals. We start in Civil 3D, utilizing the road geometry to create the initial bridge. Infraworks creates the bridge along the alignment using built-in heuristic rules. We can then interact directly with the bridge structure, changing the individual components of the bridge using the parametric toolset. Where there are repetitive tasks, or where geometry may depend on formulae, a spreadsheet can be generated, edited, and then used to update the model. During the optioneering phase, it is possible to utilize the integrated analysis and design tools. These will provide valuable feedback during the optioneering phase to help identify workable solutions in a clear and easy to understand format, providing detailed calculations for the girder design when needed. When changes are made in Civil 3D, perhaps to allow for a change in the road alignment, these can be accommodated by refreshing the Civil 3D data source within Infraworks. The bridge structure will, in turn, automatically rebuild parametrically. The bridge structure can be published to Revit at any time, with the new transfer process giving additional flexibility in the use of customized Revit templates and the category mapping features providing reports based on mapped category bridge parts. When changes do occur, those can also be easily accommodated by publishing an updated version of the bridge, together with notes identifying the changes made. Work in Revit can continue concurrently with bridge modeling in Infraworks, carrying out detailed modeling tasks such as rebar detailing and the creation of sheet sets for general arrangements and details. It is also possible to bring the bridge model back into Civil 3D to assist with grading tasks and to create further documentation such as developed long sections. And again, where changes are made to the bridge model, those can be reflected in Civil 3D by refreshing the dataset. This newly released enhanced bridge design workflow provides a means for bridge professionals to rapidly develop multiple design options through the use of powerful parametric modeling technology and progress those designs with automated documentation production systems, bringing further efficiency gains to the bridge design community.
There have been several new features added to Civil 3D 2021 around pressure pipes, focusing on pressure network layout and editing. Now you can break down a pressure pipe network into specific pipe runs. This allows a user to have an overall pressure network for the entire project, but have the flexibility to break that network down into specific pipe runs, like water main A, B, C, etc. When a horizontal change is made to the pipe run, any bend or elbow that is affected will update to the correct angle automatically. No need to manually update the bends after a horizontal change. When a pipe run is added to a profile view, you now have the ability to control the vertical offset of the pressure pipe. You can set a specific surface or vertical profile for the pipe to follow, then set the vertical offset from the surface or vertical profile. If a change is made in the surface or vertical profile, the pressure network will update to follow. Greater flexibility for editing the pipe network and profile lets you create pipe lowerings more efficiently when utility crossings occur. Now when a user extends a pipe run, at each horizontal bend location, the appropriate elbow is added. No more manual process of adding elbows after the extension has been laid out. A pipe run can also be generated from an object. In the dialog box, you have an option to set the horizontal offset distance. This will create a pipe run that mimics the geometry you are offsetting from. Using the pipe run that we've just created, we can now extend the pipe into another pipe in the network and add a branch fitting, which will place the appropriately sized T at the intersection location of the two pipe runs. The user also has the option of creating a curved pressure pipe. From the manufacturer, the pipe has an allowable deflection, so a curved layout is created instead of having to add multiple bends when installing around a curve.
Enhancements to Dynamo for Civil 3D make running scripts easier and more intuitive. Users can specify the input nodes and produce dynamic scripts. With Dynamo Player, users can run scripts, view input values, and edit scripts. The scripts and values can be processed over and over as needed. Dynamo Player makes this experience much more interactive. Users can adjust the input values, rerun the script, and quickly view the results. Users have the option to set the corridor name, the baseline, and other items as input values, so these routines can be used again in other design files. Design automation with Dynamo makes creating alternative design concepts much easier. Users can create and revise design alternatives in a fraction of the time it takes to create these elements manually. When the design is modified, scripts can be easily processed again. Dynamo operates with trace data, meaning it will remember the elements that were created and regenerate the objects based on the revised design. Dynamo Player allows users to view the scripts and edit the details when required. Dynamo Player is a simple but powerful way to utilize Dynamo for Civil 3D. Dynamo for Civil 3D has added several new functions to increase the efficiency of design workflows. Users can utilize the mText feature to create specific labels in their plans and drawings. These labels can be updated and modified in a fraction of the time it took to create the labels previously. Additional functions and capabilities for Kogo points give users greater control. Users can create Kogo points based on existing features in the drawing and provide details and accurate descriptions. Users can now add property set data to specific items as they are created with Dynamo. Users can attach property set data to enhance the detailed information within the drawing or extract property set data from existing elements to sort the items or generate detailed reports. Autodesk has created additional node packages, such as the Civil3D Toolkit found in the Packages drop-down menu. These tools greatly expand the capabilities of Dynamo for Civil3D. With these tools, users can automatically generate drawing legends or keys based on the design elements found in the drawings. Dynamo makes updating entire pipe networks quick and efficient. Users can easily modify parts and update pipe sizes within seconds. Users can also create surfaces and solids for design areas and extract volumes and quantities for each material. These automated features will help to expedite the design alternatives process and improve design quality by saving time and enhancing the overall design experience.
With BIM 360 Design's collaboration for Plant 3D, team members can work efficiently together and access plant project data stored centrally on BIM 360. The project administrator sets up the project collaboration space, and then team members can be added to the project and the appropriate permissions set, providing access control for all project stakeholders. Project members can then start work, sharing their data as the project progresses. The P&ID drafter, for example, will share the P&ID schematics to the project, and the piping designer will then create the 3D piping model using the shared P&ID data as a guide. Other members of the project team, using the shared piping model, will then generate the necessary ortho and ISO drawings, including, as well as other documentation, bills of materials, which are then also shared to the BIM 360 design project. The project manager can check the progress of the project and assign tasks as part of the review process to other members of the team. BIM 360 Design Collaboration for Plant 3D gives you the power to extend project data to all stakeholders for greater visibility and more informed decision making. The Revit connector for P&ID creates a connection between Revit and the Plant 3D P&ID schematic diagrams to enable pipe modeling in Revit. Once Revit has connected to the Plant 3D collaboration project, the P&ID diagram is available in Revit, together with a list of components contained within the P&ID diagram, which can then be utilized in the model directly. Each P&ID part is color-coded to ensure correct usage and positioning. The Revit connector for P&ID creates a connection between Revit and the Plant 3D P&ID schematic diagrams to enable pipe modeling in Revit. Once Revit has connected to the Plant 3D collaboration project, the P&ID diagram is available in Revit, together with a list of components contained within the P&ID diagram, which can then be utilized in the model directly. Each P&ID part is color-coded to ensure correct usage and positioning.